a point on the line. I'll go ahead and say that again because I wasn't recording. That's my bad. So this linear equation formula, the technical name for it is slope-intercept form. Slope-intercept form. The two numbers that we're going to see are the slope, which is our m, and the y-intercept, which is our b. That's why it's called slope-intercept form. The x and the y, when we're writing out this linear equation, are going to stay as an x and a y, just like we saw. But if we want to figure out what one of the y values is, we can plug in a given x value and solve. And solve just like we saw in the warm-up, okay? So x and y represent the x-coordinate and y-coordinate of any point on this line. Y equals mx plus b. To review again, the y-intercept is the point on your line where the x-coordinate is 0. The point on your line where the x-coordinate is 0. For example, if we have the point 0, 2, okay, 0, 2. This tells us that b is equal to 2 right away because our x-coordinate is 0. Like we said in the warm-up, the point 0, 2, if we were to plot that on a graph, lands on the y-axis, which makes that our y-intercept. Okay, and we'll see visually what this looks like in a little bit once we get our graphs glued in. Also, if we have the point 0, 4, what would my b value be on a line with this point? -4. B is equal to -4. So whenever you see an x value of 0, the more we do this, the more your brain will get trained to understand this. But whenever you see an x value of 0, whether it's in a point like this or if it's on a table like we saw in the warm-up, your brain should immediately tell you, there's my y-intercept -4, or there's my y-intercept +2. So, we're going to break down exactly what we did in the warm-up into 4 nice, easy steps. The first step being, plug your x values from the table into your equation and solve for y. Plug the x values from the table into your equation and solve for y. Step 2, add each y value into your table. So once you solve for y, you're going to throw it on that table, again, just like we did in our warm-up today. add each y value into your table, and identify each point's coordinates. Remember, the coordinates of a point are just an x value and a y value. So whatever the given x value you plugged in, and whatever the y value that you solve out of that equation, boom, that's your point. The x, comma, the y. Once you identify the point's coordinates, well, it's going to be nice and easy for us to plot each point on your graph. And finally, once we have all 5 or 4 or 3 of our points on the graph, however many you get in the table, you just have to sketch the line through those points. Now, the reason why I use the term sketch instead of saying just draw the line is because on your state test at the end of the year, they're going to be using this term a lot. Sketch the line. That just means draw the line. Okay? Yeah, state test at the end of the year. What is it called again? It's like the SBAC, I think.
Oh, yeah.
Yeah, the 4 days of testing in your advocacy class. All kinds of fun.
Oh, it was kind of cool. It was.
There's definitely some mixed opinions about the SBAC. I know in 7th grade you only test for 3 days, right?
Yeah.
Yeah, 8th grade you test for 4 days because you also have the science test you have to do. Yeah, and the science test has a lot of math in it too, so hopefully you love that. I mean, we learned scientific notation last unit, right? That's math, but it's also science. You know what I mean? Anyway, those are our 4 steps. Nice and simple. So let's go ahead and start an example. Let's say we have the linear equation y is equal to 2x plus 1. Does everybody have their ID cards on them?
No.
If you have your ID card, go ahead and take out your ID card real quick. We're going to have to draw some lines. And I would supply some rulers in the supply boxes, but some individuals have decided to glue my rulers together, and I don't like that at all. Okay? So you got your own rulers now. It's your ID card. Hopefully you don't glue your ID cards together as well.
I don't have my ID card.
Your lines are going to be wobbly, sir. Okay, I'm not saying it was someone in this class, but you know what I mean? It's just not cool, man. Not cool. I don't appreciate that. So if you were the individual who decided you wanted to just play with the glue, play with the rulers, I would definitely take a deep look within and understand why you might want to do that to something that's not your property, right? So it's unfortunate. What's that?
Yeah.
I don't know. It's not like I have numbers on the boxes. Last year I did have numbered boxes like this for group 3, group 4, group 5. But I didn't think it was important this year to do that because I thought, the trust was there, but I guess not. So it's all right. Go ahead and make sure everyone has a glue stick real quick. We're going to get some grids glued in. And we're going to use those ID cards to draw our nice straight lines. Actually, no, yeah, we're going to do 2.
With this question? Oh, you gave me 3.
We're going to do 2. I gave you 3?
No.
No, there's only 2. I know, that's what I was sure that's it. We're going to do 2 examples. So just one for this first one. It looks like a lot of us don't have space on this page.
Oh, I have.
No, we'll just flip it over. Two for each. Jackson, that was yours. Everyone got 2 graphs? So we are going to get these glued in. Do I have room? Not really. I'll make it work. I just got to cut.
Yeah, I don't have one.
Just go on to the next page. That's fine. Cool. Just one. Boom, there is our little graph. And I might not even have room to do all this, but we will try. What's up? One more time? The paper? I think the paper's a little too thin to use as a ruler. The ID cards are nice and thick, though. Yeah, make that little table. Wherever you can fit it. Wherever you can fit it. As long as you know that it's all one problem. Our x coordinates here are going to be 0, 1, 2, 3, and 4. So we're going to set this equation up 5 times, taking our x out and replacing it with each of these 5 x values. I'll give you guys a second to get all that set up before we actually start working. We'll get our points, we'll plot them, we'll draw our lines with our ID cards. All right. If you're still catching up, take your time. We're going to go through this. My step 1 that we wrote down was to plug your x values from the table into your equation and solve for y. Here's my equation. What's the first x value that I want to plug in from my table? 0. So we'll do 2 times 0 which is 0, plus 1, which equals 1. So my first y value there is going to be 1. What x value am I going to plug in next? 1. 2 times 1 gives us what? 2 plus 1 gives us 3. That's my second y value right there. What do I plug in next? Next we're going to plug in 2. 3 will be next. 2 times 2 gives us plus 1 equals 5. Start out with something nice and simple. Now we're going to plug in 3. 2 times 3 gives us what? 6 plus 1 gives us 7. Do you guys see a pattern with these y values here? They're all negatives. That's right. They're all 2 numbers apart. 1 to 3 is plus 2. 3 to 5 is plus 2. 5 to 7 is plus 2. What was our slope here? 2. Oh, look at that. It's all connected. It all makes sense, right? The change in y on our table lines up perfectly with our slope. So what's my last y value here going to be, do you think? 9, exactly. Let's check it, though. 2 times 4 is 8. 8 plus 1 gives us 9. So now we have 5 points to plot on our graph. We've got 0, 1, 1, 3, 2, 5, 3, 7, and 4, 9. This is Mr. Church. Yes, absolutely. No problem. Let me flip this. All right, so we're going to go ahead and plot these points now. First point, 0, 1. How many spaces are we going to go left and right if we start in the origin? If we're going 0 spaces on the x, do we have to move it all? No. So we'll just go 1 space up and make our point. This point right here is our y-intercept. Okay? If we look back at our equation, y is equal to 2x plus 1, what would my value of b be for this equation? Well, it's y is equal to mx plus b. So my b is going to be 1. And that lines up with exactly what we have here on our table. Whenever we see an x value of 0, the y value for that 0 is always going to give us our y-intercept, which in this case is 1. The next point we have on our table is 1, 3. So if we start at the origin, we're going to go 1 space on the x-axis, that's to the right. And then we're going to go 3 spaces up on the y-axis right there. This is why we started out the unit by practicing plotting our points so that we're nice and comfortable with it by now. 2, 5, we go over 2, up 5. 3, 7, we go over 3, up 7. 4, 9, we go over 4, up 9. And you should see a nice straight line forming on our graph. If your line is not perfectly straight, something went wrong. Double check that and make sure that you've got everything correct. The last step, step 4, is to sketch our line through those points. That's what it's going to look like. A nice straight line through all 5 of those points. Like I said, that point right there where the line crosses our y-axis, that's our y-intercept. Quick show of thumbs. How does that process seem to you? Thumbs up if it seems pretty straightforward. Seems like you got it. Thumbs sideways if it's a little bit confusing, maybe a lot of work. Where are we all at? I'd like to see everyone's thumbs just to check in to see where we're at real quick. Okay, good, good. All right, I'm going to leave that there for a couple minutes or a couple moments for you to get that done, and then I'll flip over for us to do our next example. Okay. How's our homework? Finish copying up if you're still writing that down. What's that? DAN? I have no idea. I know ASB is Associated Student Body.
Oh, what is that? The dance.
Wait, what does it say? DAN?
Yeah, that's a
Oh,
dance.
that's dance. Yeah. Good call. Well, I didn't know. I don't go to the, well, I do have to go to the dance, but yeah. I have to make sure no one's bumping and grinding. You know what I'm saying? All right. Flip it on over. Let's see. Let's go ahead and do another example. Let's say we've got the equation y is equal to negative 1/2 x plus 3. I got a whole bunch of space here now, so I don't have to cram everything in. Good. I'm going to do my table up here. And my x values here are going to be negative 8, negative 4, 0, 4, and positive 8. If you're asking yourself, where are we getting these x values from? That's part of the problem that's given to you. Okay? So it's not like you have to come up with numbers. You're going to see on worksheet 17 here in a bit that you get all those x values to start with, okay? All you have to do, like step 1 says, plug in the x values and solve for the y, okay? Which is what we're going to do right now. So we've got negative 1/2 times something plus 3, negative 1/2 times something plus 3, negative 1/2 times something plus 3. I'm not going to keep saying it, but you know what I mean. Just like that. All 5 of them set up, ready to go. I'll glue my graph down once I know where I have room to glue it down. So just hold off on that for now. All right, what's the first x value we want to plug in here? You guys okay? Okay. First one, negative 8. Plug that in right there. Now, with this negative 1/2, I want to take this a little bit. I'm going to break this down a little bit more. What is negative 1/2 times negative 8? Positive 4. Right? Negative times a negative is a positive.
But you have to do plus 3.
Half of 8 is 4. That's right. We'll do plus 3. And that gives us a y value of 7. Boom. Then we plug in negative 4. What's negative 1/2 times negative 4? Positive 2. 2 plus 3 gives us 5. That's my second y value there. What's negative 1/2 times 0? 0 plus 3 gives us 3. Bless you. What's negative 1/2 times 4, though? Well, what's half of 4? 2. And a negative times a positive gives us a negative 2. And negative 2 plus 3 gives us close. If we have negative 2, closer. Positive 1. There we go. Positive 1. Good. Remember, if you start at negative 2 on the number line and you're adding 3, you go 3 spaces to the right, 1, 2, 3, you end at positive 1, right? You could also think of it like, well, what's the difference between 2 and 3? That's just 1. And my bigger number here, 3, is positive, so my answer is going to be positive. Let me plug in 8. What's half of 8? 4. And with a negative times a positive, we get a negative 4. Now, negative 4 plus 3, that's going to give us what? Close? Negative 1. The difference between 3 and 4 is 1, but the bigger number here, 4, is negative, so my answer is going to be negative. That's the way that I think about it. Hopefully that helps. If not, use the number line. The number line will never change or fail you. It's always going to be the same number line every time. So, we got our 5 points. Got a nice space for my graph right here. So let's take a few moments to get that secured. Some of these glue sticks are purple. I didn't even know that. What's my y-intercept of this graph? What's my b value here? What's my b value? 3, right? Now, when my x is 0, my y is 3. Just like we said, that's going to be our y-intercept. The reason why I'm stressing the y-intercept so much is not only because it's a new idea to us this year, maybe, but it's also because with what we talk about tomorrow, the y-intercept is going to be our starting point when it comes to graphing. You may be thinking to yourself, geez, this is a whole lot of work just for us to get 5 points to graph. We're going to learn, if you think that, that's okay. We're going to learn a shorter way to do it tomorrow. But this is basically the why. And then we'll worry about the what tomorrow. So let's plot these points. Negative 8, comma, 7 is my first point. So I start at the origin. Am I going to go 8 spaces to the left, to the right, up, or down here? If I'm going negative 8 on the x-axis. Close. Not down. Down would be the y. We're going to go left. Thank you. That's right. Negative 8 on the x, positive 7 on the y, all the way up right there. Negative 4, comma 5, we go to the left 4, we go up 5, boom. 0, comma 3, like I said, that's my y-intercept, so it should land right there on my y-axis, which it does, thankfully. my fourth point, 4 comma 1 right here on the table. We go over 4, up 1. And then we'll go over 8, down 1 for 8, negative 1. Once again, there's no tricks here. You should always get a perfectly straight line. If your line is not perfectly straight, double check and make sure that you not only plotted the points correctly, but make sure that you have a constant change on our y and our x. Right? And we've talked about the change in x and the change in y from a table. How would we get from 7 to 5? Minus 2. How do we get from 5 to 3? Minus 2. What about 3 to 1? Minus 2. And 1 to negative 1? Minus 2. What about from negative 8 to negative 4? 2 plus 4 from 8 to 4 plus 4 plus 4 plus 4 and plus 4. Right? So if our change in x is plus 4, our change in y is minus 2, that means that our slope, which would be the change in y over the change in x, we'll move this down right here, change in y over change in x should be minus 2 over positive 4. What would that simplify to? Negative 2 over 4? Negative 1/2, right? So we can see from our table, our slope is negative 1/2. If we look at the graph here and did rise over run, we've got a rise down 2. We've got to run over 4. So the rise over run would also be negative 2 over 4, which is negative 1/2. Right? Just to review from earlier in the unit. Now, what number do you see in front of x in our original equation? Negative 1/2. Look at that. It's all the same. Negative 1/2 we got from the table, doing our little arrows. Negative 1/2 we got from our graph, doing rise over run. And just like we talked about on Monday with worksheet 16, that number right in front of x is always going to be our slope as well. Negative 1/2. Now, if we have a negative slope, what should our graph look like from left to right? Should it look like it's going uphill or downhill? Downhill, right? Negative, downhill. Does this line that we just graphed look like it's going downhill from left to right? Yes, it does. So I may be giving you a little bit of information overload right now, going back to all our old stuff. But it's just to show you that everything we've learned on blue paper is connected. Now we're just putting it all together. And that's a whole lot of work for that example. But trust me, the more we do it, the more comfortable we get, the quicker it's going to be, the more confident you're going to feel.